to specialization.com. Your requested project is Wormhole Attack Detection Algorithms in Wireless Network Coding Systems. Now we move into the abstract. Network coding system has been shown to be effective approach to improve the wireless system performance. However, many security issues impede its wide deployment in practice. Besides the well-studied collision attack, there is another severe threat, that of wormhole attacks, which undermines the performance gain of network coding. Since the underlying characteristics of network coding system are distinctly different from traditional wireless networks, the impact of wormhole attacks and countermeasures are generally unknown. In this paper, we quantify wormhole devastating harmful impact on network coding system performance through experiments. We first propose a centralized algorithm to detect wormholes and show its correctness rigorously. For the distributed wireless network, we proposed on a distributed detection algorithm against wormhole in wireless network coding system. By exploring the change of flow direction of the innovative packets caused by wormholes, we rigorously proven that DAWN guarantees a good lower bound of successful detection rate. We perform analysis on the resistance of DAWN against collision attack. We find that robustness depends on node density in the network and prove a necessary condition to achieve collision resistance. DAWN does not rely on any location information, global synchronization, assumptions, or special hardware or middleware. It is only based on the local information that can be obtained from regular network coding protocols, and thus the overhead of our algorithm is tolerable. Experimental analysis have been verified that effectiveness and efficiency of DAWN. Next we move to the flow diagram. First we sending a data by routing and packet conversion. Next we detect and localize a wormhole link on RLNC system. Next process is wormhole attack in wireless network coding system. In this using in-text data mining algorithm. Next is a centralized algorithm. To overcome wormhole attack in RLNC, we propose a centralized algorithm. In this algorithm, a central node which gather information from all the neighbor nodes which increments the rank. Next is a distributed detection algorithm. It is to detect wormhole attack in wireless network coding system. Next is the algorithm design. Report back a direction observation result to its neighbor. Detect whether any attacker exists. Next is a collision resistance of DAWN. Our proposed distributed algorithm can perform with a lower bound of detection rate. Next is the attackers can be smarter. DAWN requires collaboration of wormhole attackers, neighbor nodes, that is monitoring attacks, sending, forwarding and analyzing reports. Next is a lower bound of detection rate. Attacker can manipulate wormhole link more intellectually. Next is the impact of amount of judge nodes of a DAWN is a graph. Next, collision resistance of DAWN. Capability of DAWN in resisting collision among judge nodes. Then stop the process. Now we run the project. The first form is a network deployment. I am going to select the address button which will display user IP address in the text box. I am going to select a network status which contain network information that will be displayed in the text boxes. And I am going to select a signal status which contains the signal information will be displayed in the text box. When I move to the next form as a node cost, I am going to select a view connection from the combo box. A node will be displayed in the preview 1, and I am going to select the cost. A node with the cost value will be displayed in the preview 2. Then I move to the next form is a RLNC approach. I am going to select a wormhole link, a source node, destination node, cost will be displayed in the preview 1, and I am going to select a deactive link, a source node, destination node, cost will be displayed in the data preview 2. Then I move to the next form, the node connection. I am going to connect a node. I am choosing wait. A node will be displayed here with X value and Y value. I am going to select a source node and I am choosing source page which will display source node with X value and Y value. I am going to select a destination node and I am choosing destination range which will display destination node with X value and Y value. Then I move to the next form is a data allocation. I am going to allocate the data. I am choosing node which will display node with the data. I am choosing node 3 and I am going to allocate the data for, I am choosing 310 which will be displayed here. I am going to allocate data 320 and I am selecting schedule data, packet data sent, OK. I am choosing data transfer. For 310 I allocated data to 320 which will be displayed here. Then I move to the next form. It's a centralized approach. I am going to select a loadability. A list box will be displayed here. I am going to select a path and then choose transmission button. The path which I selected here will be displayed in the text box. When I move to the next form, the selected path will be displayed here. I am going to choose a 5 and I am going to select a open and I'm going to send the file. File transferred successfully. Okay, I'm going to select a get button. The message box will be displayed here. Then press yes and select a process button. The processing data and the time will be displayed here. Then I move to the next form. It's a down approach. I'm going to select a transmit button. The data ready to transmit. Okay. I'm going to select a find wormhole. The wormhole attack will be exist here. And I'm going to analyze. Then I move to the next form. A graph will be displayed here. I'm going to select a schedule. A schedule data graph will be displayed here. I'm going to select a time. The time taken will be displayed in the graph too. Then I move to the next form. It's a node with x value and y value. I'm going to select the first button, which will display a node and x value in the graph 1. And I'm going to select a button 2, which will display node with y value in the graph 2. Then I move to next form. I'm going to select a unicast, which will display unicast graph in graph 1, and I'm selecting broadcast, which will display in graph 2. Exit, application exists. Thank you.